Hello all. Today I am going to deal with the topic concept of rest and motion. Today we'll be learning about the three main topics. First one is frame of reference and types of motion and motion in dimensions, that is in 1D, 2D and 3D. So first we'll be seeing about the frame of reference. So think about it. Why does a moving bus make you feel like nearby trees are moving backwards? Okay, did you think about it? Yes. So the answer for this happens because of relative motion. So when you are sitting in the bus, the frame of reference is the bus itself. So since you are moving forward along the direction of the bus, the stationary objects like trees appear to move in the opposite direction. Okay? So in reality, the trees are not moving. Their position are fixed to the ground. But because of your position is continuously changing, your brain interprets that these trees are moving backwards. Next is like what is actually a frame of reference is that it's a coordinated system. We'll be considering it as x, y and z. So the viewpoint used to measure the position and motion of the object is called as the frame of reference. So it helps to describe whether the object is at rest or motion. Is it moving or it is stable, it is in rest position. So motion is relative, meaning it depends on the observer. Next we'll be seeing about the types of motion. There are four types. One is linear motion, circular motion, rotational motion and vibratory motion. So there are four types of motion. First we'll see about the linear motion. So linear motion is that an object is said to be linear motion if it moves in a straight line. So if it moves in a straight line, it is called as linear motion. So example, an athlete running on a straight track, a bus moving on like on the straight road, it's all considered as the linear motion. So it can be vertical as well as horizontal. Vertical means and a particle falls vertically from downwards towards the earth. Next we'll be dealing about the circular motion. So circular motion is defined as the motion described by the object traversing a circular path. So it actually moves in a circular path, that is called as a circular motion. So the wailing motion of a stone attached to a string. You attach a string to a stone, then you rotate it. So it will form a circular motion, not rotatory motion. Okay. So the motion of a satellite around the earth is also known as a circular motion. Next is rotational motion. So if an object in a rotational motion about the axis, the motion is called rotation. So during the rotation, every point in the object traverses circular path. So each object will be like traversing a circular path about an axis. So example for this is rotation of the earth's axis. You can call an example of a fan also. The fan position axis is fixed, but the wings are rotating. So about a fixed point, the wings are rotating is called as the rotation motion. Next we'll be dealing about the vibrational motion. So if an object or a particle like executes to and fro motion, about a fixed point is said to be in a vibratory motion. Like we'll take a simple pendulum. So the point will be fixed and it will be oscillating. So vibratory motion is also called as oscillatory motion. So the example is this vibration motion of a string on a guitar. When it actually vibrates, right? So this is the guitar is known as a example of a vibratory motion. Next, okay, to understand this concept in a better way, let's have a quiz time. So the first question is, the motion of a ceiling fan is an example of, can you guess? The options are A. Circular motion, B. Rotational motion, C. Linear motion and D is vibratory motion. The answer is B. Rotational motion. Did you get it correct? Yes. We'll be moving on to the next question. Which type of motion is shown by a car moving on a straight road? Think and answer, girls. So the option for this is A. Circular motion, B. Rotational motion, C. Linear motion and D. Vibratory motion. Did you guess it? Yes. The answer for this is C. Linear motion. Okay, that's it. Next, we'll be dealing about the motion in 1D, 2D, and 3D. So, motion in one dimension. One dimension is that x, y, and z axis is the coordinate system we have. So, x and y and z coordinates. When these coordinates changes with time, the particle is said to be in the motion. However, it is not necessary that all the three coordinates should be together, that is, they should together change with time. If one changes also, it is accepted. So, if one or two coordinates changes with time, the particle is said to be in motion. Motion in one dimension. That is, a one dimensional motion is the motion of the particle moving along a straight line. So, it is called as a rectilinear or a linear motion. So in this, what happens is only one of the three rectangular coordinates are specifying the position of the object that changes with time. That one, there are three coordinated system, that is x, y, and z. Here the x is only moving. So what happens is the car is in motion. So it travels from here to here. So the x is alone changing. The y didn't change. This is xy. You keep it as xy. So the x alone changing due to the car is moving in a straight direction. Okay. So in this we'll be considering about the x coordinate system that changes with time. It equals to motion. So motion in two dimension. If a particle moving along a curved path in a plane, then it's said to be in a two-dimensional motion. Let's talk about the projectile motion. So it travels from one position to another position. So like in this y and z plane, the two coordinated system are playing the major role. So x is at rest and y and z, these two coordinates are used, so it is in two-dimensional motion. Next, we'll be seeing about the motion in three dimension. So a particle moving in the three-dimensional space has three-dimensional motion, three dimensions. So it moves in a three dimension. In this motion, all the three coordinates specifying the object of the position of the object changes with respect to time. So when the particle moves in three dimension, like the x, y, and z, three will vary. Okay. So the example for the three-dimensional motion is the bird flying in the sky and a kid is playing with a kite on a windy day. So these are the example of three-dimensional. Let's move to the summary part. So today we'll dealt with what topics? Three topics: frame of reference, types of motion, and motion in dimensions. So frame of reference is that viewpoint used to observe the motion depends on the observer. So types of motion is that there are four types: linear, circular, rotational, and vibratory. Linear motion moves in a straight line and circular motion moves in around a circular path, and rotational about a fixed axis the motion will be there. For the vibratory motion, there will be to and fro motion of the mean position. So next one is that we dealt with motion in dimensions 1D, 2D, and 3D. Next, recapitulation. So I have given about the 4 short answer question and application based 4 questions. So try to answer these questions in the comment box. I'll be waiting to see your responses. So I'll be reading out the short answers. So for the short answer, first question, how does the frame of reference affect the motion? Next, second one is, give one example of each linear and circular motion. So difference between rotational and circular motion, because you will be having a confusion about circular and rotational are the same, right? Then why is the difference between, what is the difference between the two of them? Analyze and answer. So fourth question is that what is vibratory motion called? Periodic motion. So it is called as an oscillatory motion. It is also called as a periodic motion. So try to answer this question. So then application based question is, there are 4 questions. Why do trees appear to move backwards when we are in a moving bus? Second one, a fan is rotating. Identify the motion involved. Classify the motion of the moving car on a curved road. What type of motion does the vibrating toning fork show? So these are the questions. So try to answer this in the comment box. That's all for today. Thank you, students.